All right, hello everybody for quick math in a minute. What we're going to do today is run through an example of linear functions in this. This is basically a graphic organizer that shows the 4 different ways we can represent functions. And in this particular case, linear functions. Typically up here in the top left, those are your x, y coordinate pairs. You can write them as xy or x, f of x. And then in your top right is your graph. In the bottom, you have your main algebraic expression, and then x-intercepts and y-intercepts, which are 2 of the important points about that function. And then in the bottom right, as you know, we can write linear equations in 3 different ways: slope-intercept, standard form, and point-slope form. And so I'm going to quickly put those formulas in. Y equals mx plus b. Standard form is ax plus by equals c. And point slope is y minus y1 equals m times x minus x1. So basically, whenever my goal is no matter what information you're given, that you'll understand where it comes from and how it relates to all these other forms and easily be able to go between the different forms. So that is going to take some practice. Okay, so in this particular case, we're given a bunch of xy coordinate pairs, so we're given numbers, and we need to find the rest. I would say lots of interesting places to start, but let's start by thinking about what an x-intercept is. So that's where it crosses the x-axis. So by definition, f of x or y, we use those interchangeably, is equal to 0. So we can actually find that in our table of numbers here. So we know our y-intercept from the table of numbers is 2, 0. So at our x-intercept, so x-intercept. So we're going to plot that point, x equals 2, y equals 0. Likewise, for the y-intercept, that has to happen when x equals 0. If you're going to be somewhere on the y-axis, x by definition is 0. And we can also find that point in this table. And that's located at 0, 2. So it's right here. All right, so let's write that. That's right here is the y-intercept, and right here is the x-intercept. Okay, we're going to actually come back and see how we could also solve for those algebraically after we have one of the equations. We can see, though, where the numbers are located in the table is related directly to where they're plotted on the graph. Because the table numbers are the xy coordinates, they are also related to x is your input, and then f of x or y is your output. So whatever number you put into the equation as x, what you get out is represented by f of x or y. So I think probably the next step is to go ahead and plot some more of these points, just to remind ourselves how to do that. I don't have room to plot the minus 10 and the 10 input points, but for x equals minus 5, I get 7. 5, 6, 7 is right here. So whatever this equation is, if I put in x equals minus 5, what comes out, f of x is going to be 7. If I put in minus 2, what comes out is 4. So it's going to be right here. And then minus 2, I got minus 2, minus 1, and 3. So if I go to x equals minus 1, I plot 3. If I go to x equals 1, I'm going to plot 1. And if I go to 5, and x, 3, 4, 5, I get to minus 3. Great. I am not the best at drawing straight lines, but I will do my best here. Yeah, that's not super straight, but just pretend it's straight. Make that a little better. All right, so this blue line represents the output of our function f of x or y, And what it basically means, like literally means, is you can go anywhere on this x-axis, way beyond what I've graphed here. And whatever x value you choose to put in, let's say you put in 1,000, which is way out here somewhere. Then when you go look and see where it intersects that line is going to actually be the solution for that point. So when you put in x equals 1,000, whatever comes out is going to lie on this line. And that algebraic expression that describes this line is nice because it's a really compact way of showing what this graph shows, which is the match of output for every input. So I think let's go ahead and find the first form of algebraic expression, which is slope-intercept form. It's my favorite. So we know b already, right? So b is going to equal 2. We just need to find slope. And we know slope is rise over run, y2 minus y1 over x2 minus x1. And you can actually find it by looking at the graph. So we can see, if I look at any pair of points, my point that's further to the right, in order to get to it from my first point, I'm going to go down 1 for every time I go over 1 to the right. So it's minus 1 vertically, plus 1 horizontally. So my slope is going to be minus 1 over 1. I can also do it from points, and I can pick any 2 points. They don't even have to be adjacent points. I'll pick these 2. So I'll use these 2 points for slope. All right, so this is my second point. There's my first point. So first I'm going to subtract the y. So it's my second point minus my first point. And then I'm going to do x, my second minus my first. So the bottom's easy. I have 10 minus 5. At the top, I have minus 8 minus a minus 3 becomes minus 5. Or, as we figured out graphically, m equals minus 1. And it's true for any 2 points on this line. And you can even we could use 10 comma minus 8 and minus 10, 12. And we'll get the correct answer for m, or slope. So let's write this as an algebraic expression. Y is equal to mx with minus x plus b. Or function notation, we would write f of x equals minus x plus 2. Now this is a little bit either more or less abstract depending on what kind of thinker you are. But in my example before, if I put in x equals 1,000, which is way off the graph, well, if I put in x equals 1,000, I multiply by minus 1, so I have minus 1,000. I'm going to add 2, so I'm going to end up at minus 998. And that would be my y-coordinate point, my f of x. To say it in a different way, if you, the listener, are in charge of being the function, no matter what input value I toss to you, you're going to take that value and you're going to multiply it by minus 1 and you're going to add 2. So if I give you the point x equals 8, you're going to multiply it by minus 1. That gives you minus 8. You're going to add 2, and your output's going to be minus 6. And if you think about that on our graph, that looks right. If you go to 8, then where you're going to hit the line is down there at minus 6. Works nicely. They don't have to be integers either. Let's say I toss you the point that's the rounded pi. If I give you 3.14, you're going to multiply by minus 1. That's going to give you minus 3.14. And then you're going to add 2. So you're going to end up with minus 1.14. Anything you want you can do, which is why this expression of y or f of x equals something is so powerful. And we've actually done just about everything now. Let's algebraically do, we have to do the other slope-intercept forms. So this one we know is y is equal to minus x plus 2. All right, well, to get it in standard form, I just need to move the minus x, add x to both sides. So I'm going to end up with x plus y is equal to 2. All right, so this is one form. There's the second form. And to go from this one to this one, I added x to both sides. One of the things that working with linear function different forms does for you is strengthens your practice in solving equations. All right, so point slope form, I can again use any point I want. I'm going to choose the point, let's pick minus 2 comma 4. So I get y minus 4 is equal to minus 1 times, so I'm just going to write minus x minus minus 2. So y minus 4 is equal to minus x plus 2. And that is our point slope form. Now we have all three of those. Last thing I'd like to do is solve algebraically for x and y intercepts. So we know how to find them in a table. You know how to find them in a graph. Finding them algebraically turns out to be very useful for other kinds of functions. So the x-intercept happens when f of x is equal to 0. So I go to my equation, and I want to find x when f of x equals 0. So I'm defining f of x to be 0, and I'm looking for what x makes that true. So what input can I put into this function so that the output is equal to 0? So 0 is what I know, minus x plus 2. I want to solve for x. So I'm going to subtract 2 from both sides. I'm going to multiply both sides by minus 1, and I'll find that x equals 2, which matches what we knew. Similarly, to find the y-intercept, now I want to find a y, and I know that x equals 0. A lot of times you'll see this written as f when x equals 0, or f of 0. So make sure you see the difference between f of x equals 0 and f of 0. So if I want to find f of 0, what that's telling me is x is 0. So everywhere I see x, I put in 0. So I have minus 0 plus 2, or f of 0 is equal to 2. And that is our y-intercept. And that's it. Now we're done.